Bioluminescence, the ability for an organism to produce and emit light, has convergently evolved over 40 times across the tree of life. Organisms use bioluminescence for their advantage for many different reasons, including prey attraction, mate recognition, camouflage, and predator warning. Motixia is a genus of bioluminescent millipede endemic to a few mountain ranges in California. It has a blue-green glow and defends itself with poisonous cyanide, which it emits from glands that appear along the length of its body. Studies have found that this bioluminescence is aposematic, an advertisement to predators that the organism is unpalatable and dangerous to ingest. The recent rediscovery of a Californian millipede, Zistichair bistopeda, along with a paper published by Paul Marek and Wendy Moore in PNAS, has provided new insight into the evolution of bioluminescence in Motixia, which until now was unknown. This species of millipede was discovered in 1967, but it went under the radar until 2013 when it was rediscovered in the foothills of San Bispo, California. The millipedes found in 1967 were largely undocumented, and the fact that they were bioluminescent went unnoticed. Based on this bioluminescence and a close phylogenetic relationship, researchers transferred the species to genus Motixia, renaming it Motixia bistopeda. Based on this new phylogenetic tree analysis, it was found that bistopeda evolved before the other species in Motixia. Furthermore, as the species evolved and diversified, bioluminescent intensity increased. To deduce the evolution of emitted light, Marek and Moore measured the bioluminescent intensity of 289 millipedes, which represented the 43 millipedes on the phylogenetic tree. The researchers then compared the relationship between bioluminescence and toxicity by measuring the exocrine glands on the side of the animal's body. These glands emit cyanide when the animal is threatened. They found a direct relationship between the size of the glands and the amount of toxicity. Comparing this data to bioluminescent intensity allowed researchers to conclude that Motixia with a brighter bioluminescence are more toxic. Furthermore, researchers concluded that bioluminescent intensity and toxicity are directly related to the animal's elevation. In California, as elevation increases, so does habitat variation, meaning there are more predators for the millipedes. As Motixia evolved and diversified to higher elevated areas with more predators, a brighter bioluminescence and higher toxicity became a beneficial trait. The researchers hypothesize, however, that bioluminescence evolved originally as a way for millipedes to cope with the harsh desert heat. The metabolic stress provided by hot desert environments is especially intense in these blind millipedes, which are not able to disperse easily to cooler areas. Therefore, they offset the accumulation of harmful chemicals through bioluminescence, which emits harmless photons of light. It was later on, as the millipedes diversified to higher elevations with more predators, that the function of bioluminescence underwent evolutionary exaptation to serve the different purpose of warning off prey. This new research has provided special insight into convergent evolution and the way in which organisms use bioluminescence to serve different purposes. This study of Motixia provides us with a comprehensive overview of why bioluminescence evolved in these millipedes, and how evolutionary exaptation can repurpose traits as species diversify and inhabit new environments.